Here's an example to solve this trig equation. We want to find the exact solutions for the square root of 3 times the sine of x equaling the cosine of x for 0 to 360 degrees is the domains of the first revolution. I do think the textbook does a great job in showing its work on this problem. So the first step is dividing both sides by the square root of 3, and then dividing both sides by the cosine of x. And then noticing that the sine of x divided by the cosine of x is the tangent of x. Now we tend in our class to rationalize this piece. So it'll be square root of 3 over 3, which is square root of 3 over 3. Then you would use your unit circle. This is your cosine, and this is your sine. You would divide those 1/2 divided by square root of 3 over 2, and you would get square root of 3 over 3. So one of your solutions is 30 degrees. You would also notice that if you took this set of ordered pairs and divided them, you would also get square root of 3 over 3. If you're a little confused on the work in the textbook, how you solve this equation, you may want to do it in 2 steps. So first, divide both sides by the square root of 3. Then you would want to divide both sides by the cosine of x. To remove the cosine of x from the right-hand side. Dividing by the cosine of x is the same thing as 1 over the cosine of x with multiplication. So what happens is this right side, cosine of x's will cancel out. Then we're left with sine of x over cosine of x is the tangent of x. And then we have 1 over the square root of 3. And like I said earlier, we like you to rationalize those. So square root of 3 times the square root of 3, multiply across to get square root of 3 over 3. So there's the work shown out. The 2 solutions for the first revolution for x in this equation are 30 degrees and 210 degrees.